So let's take a look at example 5. An object is propelled upward, apparently from a cannon, at an angle theta to the horizontal, means just like to the ground, right? With an initial velocity of v naught feet per second. If air resistance is ignored, because why not? The range r is the horizontal distance that the object travels is given by this function. So r theta equals 1/16 v naught squared sine theta cosine squared theta. And I want to show that this is equivalent to this. So if I take 1/16 v sub 0 squared sine theta cosine theta, and I manage to pull out another factor of 2, right? Then I could put a 2 here. So that would give me 1. Here's a better way to explain it. So first off, let's remember that sine of 2 theta equals 2 sine theta cosine theta. I have sine theta cosine theta. What if I was to multiply that by 2 on the top and the bottom? Or what if I was to divide this by 2? That would give me so we're going to multiply this by 2 on the top and the bottom. So I have 1/16 v naught squared 2 sine theta cosine theta over 2. I can pull out that factor of 1/2 and move it over here. So I've got 1/32 v naught squared 2 sine theta cosine theta, which I can then substitute with sine of 2 theta. So final answer, I have 1/32 v naught squared 2 sine theta cosine theta. Nope, I just rewrote the exact same thing. Sine of 2 theta. Now, what if I want to know the angle for which r is at a maximum? So let's note that the range for a sine function goes from 0 to 1. Well, it goes from -1 to 1, right? The range of a sine function goes from -1 to 1. So 1 would give our range the largest value if I was to substitute in 1 for sine of theta, for 2 sine of 2 theta. Well, where is sine of theta 1? Well, that's at 90 degrees, right? But I want to know when sine of 2 theta is 1. Well, that would be when 2 theta equals 45 degrees. So, sorry, 2 theta equals 90 degrees, so theta equals 45 degrees. So sine of 90 degrees would give us our max. So theta would have to be 45 degrees for our maximum range. Let's take a look at these half angle formulas that we can use to find exact values as well. If I have sine squared of alpha, that equals 1 minus cosine alpha over 2. Cosine squared alpha gives us 1 plus cosine alpha over 2. And sine squared alpha over 2 equals 1 minus cosine of alpha or 1 plus cosine alpha. Now this is great, but we aren't often asked to find the sine squared form of a particular theta. So what if I took the square root of both sides? Well, then I'd have sine of alpha squared alpha over 2 equals the square root of 1 minus cosine alpha over 2. And that gives us our half angle formulas. So here are our half angle formulas. Sine of alpha equals 1 minus cosine alpha over 2. And this is plus or minus, right? So when we take the square root, we take the plus or minus. And the plus or minus is determined by what quadrant our angle is in. So it's always really important to know what quadrant you are in. Cosine of alpha is plus or minus 1 plus cosine of alpha over 2. And tangent of alpha equals plus or minus 1 minus cosine of alpha over 1 plus cosine of alpha. So here are our half angle formulas. Why don't we go ahead and do a few examples so we can practice using these. I also want to quick point out that remember all of these are written in terms of cosine, which makes our lives a little bit easier. So if I have cosine of 75 degrees, I want to find the exact value. That means you can't punch it into your calculator and approximate. I don't want that. The issue is 75 degrees isn't on our unit circle, but you know what is? 150 degrees. So this is like saying I want the cosine of 150 degrees divided by 2. Well, I have a formula for that. That gives me plus or minus 1 square root of 1 plus cosine of 150 degrees over 2. Well, the cosine of 150 degrees, if you look on our unit circle, is actually the square root of 2, the square root of 3 over 2. So this would give me 1 minus the square root of 3 over 2. That gives us 2 minus the square root of 3 over 2 again. We'll go ahead and divide by 2. So I have the square root of 2 minus the square root of 3 over 4. We then take the square root of the numerator and of our denominator. The square root of 4 gives us 2. So this is our final answer, except first I need to figure out, is this plus or minus? So in what angle, in what quadrant is 75 degrees? Well, 75 degrees, that's in quadrant 1, where cosine is positive. So our answer is going to be positive square root of 2 minus the square root of 3 over 2. And I know we're taking the square root of a square root, but that's okay. And that's something we can actually do mathematically and continue to get an irrational number.